at electric potential. So first off, what is electric potential energy, or what would it cause it to increase? So if we're making charged particles do what they don't want to do, so we're making them move where they don't want to go, that would cause an increase in potential energy. So what does that mean? So if you take like charged particles and you move them closer together, they do not like that. That increases potential energy. And moving oppositely charged particles further apart, they want to come together, but moving them farther apart, that increases electric potential energy. So what is electric potential energy? It is the potential for electric force to do work on charged particles. The unit of that, again, it's an energy, so joules. So let's take a little deeper look at electric potential energy. So what would, in which case, if you had oppositely charged objects, which of these two would have a greater electric potential energy, this arrangement, when they're close together or if they're far apart? Correct answer is when they're far apart, because they want to come close to each other. In this thing, there's a bigger distance, and electric potential energy has a greater amount of potential to do work to bring them together. So what happens if you have the same charges on the object? Which of these two arrangements would have a greater potential energy? Where they're close together or where they're farther apart? Correct answer is when they're closer together, because they want to repel each other, and therefore you have a greater distance from here to essentially infinity away. It can move that much a lot more, do a lot more work. So when they're closer together and things are the same charge. So electric potential energy is different than electric potential. It has the same words, just not an energy associated with it. So the variable for electric potential is a capital V. It doesn't make sense at this moment in time, but it will later on. What is the equation for electric potential that incorporates electric potential energy? So this is electric potential is equal to electric potential energy over a charge, or the charge on an object. So it's this ratio of energy per charge. The unit for that, energy is in joules, and charge is measured in coulombs. Therefore, you have joules per coulomb. We have a name for that, and that is a volt. And you're like, hey, wait a minute. I've heard of those. Those aren't those on light bulbs, like voltage and volt and stuff? Like, So the abbreviation for volt is also a capital V. These two, so this may be a good thing or bad thing for you. They're both a variable, and the abbreviation or the symbol for volt are both capital V. So hopefully that's a good thing rather than a bad thing. What's the difference between electric potential energy and electric potential? They are related, but electric potential energy is the total amount of electric energy or potential energy that an object stored because the electrons are close together. We're going to focus on electrons in this class. So it's simply because they're the total amount because they're close to, they want to get away from each other. Versus electric potential is the ratio of how much electric potential energy there is for every 1 coulomb of charge. In other words, it's how much energy each electron has. So it's looking at like the ratio of energy per electron. And that's it.